Okay, then plus by m as a function of x, the whole thing will equal to 0. So m as a function of x is equal to minus px. Okay. So this again, these two are our what? Equation. Okay. So now, what I'm going to do now is I'm going to, at the same time, as I said, we're going to sketch this shear force and bending moment diagram. Okay. So as you can see from our structure, from what I'm showing now, okay, so where are the points we have to analyze? We have to analyze what is going on at point A, between point A to point B, and then we have to analyze what is going on at point B, and then we are going to look at point B to C, and then we are going to analyze what's going on at point C, and then point C to D. So we're going to create a table. Okay, so we are going to create a table. Okay, so the table we're going to create is, so we're going to analyze our at point A, right? Then we are going to go from A to B, and then we'll look at point B, and then we're going to look at point B to point C. Then we are going to look at point C. Then we're going to analyze point C to point D. And then lastly, we are going to look at point D. Okay. Then we write our distance x. Right. So x over here, right, for our case, x is equal to 0. From A to B, so it is between 0, x to A. At point B, it's going to be at A. And between B to C is A, x to L minus A. At point C is L minus A. And then at C to D is L minus A, x to L. And at point D is a distance L. Okay. Then we're going to have our equations. So this is our shear force. Equation. And then we're going to have our bending moment. Okay. So the shear force at point A is equal to minus P. Right, we have this as minus P. Right, so this is shear force V at point A. This is equal to minus P. Moment at point A, this is equal to what? 0. And then we form our next set of equation V. So whenever, so we, now this is V as a function of X. Okay, so this will be equal to minus P. And then the next one is moment as a function of X. Now that is equal to minus Px. Okay, right. So from here, I'm also at the same time, okay, before we go into B, I want to start to interpret what does this actually means on the shear force and bending moment diagram. So we're going to sketch our shear force and bending moment diagram. Okay, so we're going to do a sketch. Okay, we're going to do a sketch over here. So we will have our, so I'll draw the member for you. Okay, I'll draw the member and the load. So this is our member, right? So 3, so this is our point A, point B, point C, and then point D. So these are our load. So this is our point load. Then we have a evenly distributed load. Okay. Then this is equal to P omega, Okay, then I'm going to directly at the below, we're going to draw our shear force diagram. Okay, so this is our shear force diagram. Why I'm doing this, because later on, when you, after today's lecture, you can see what sort of load point, if a point load, how your shear force diagram look like, and then on a distributed load, how your shear force diagram will look like. Okay. Right. So this is V. So this is 0, right? And this is equal to our distance A. This is our distance L minus A. And this is our distance L. Now you can see why the datum is always on the what? The datum is on the left-hand side, right? Because 0 is always on the what? Left-hand side. The geometric datum is always on the what? Left-hand side. You can analyze left to right, right to left. I don't bother. But your geometric datum always on the left-hand side, because we are going to sketch a graph, and the 0 is going to be at where? On the left hand side. Okay, so don't gung ho and do some changes. Yeah. Okay, so that's where we always go from this side. Okay, so we know by looking over here, right? So by looking at our shear force at point A, so we have a point down here, so this is equal to minus P, right? That's our point A. And between A to B, it is still what? Minus P, so it's going to be a straight line. Okay, right? So that is our shear force diagram. Okay, and then next we do, so this is this function of that's our x. Then below we're going to draw our bending moment equation. Okay, so we're going to again do our bending moment equation. Computer not behaving. Sometimes it's the user. Okay, so this is m in moments now. And then, sorry. So again, this is our x. Okay, so 0, you have A, you have L minus A, and then you have L. Okay. Now, so what we see over here, right? When M is at point A, the moment at point A is equal to 0, so we're going to start from 0. Okay. And then from M as a function of x, between A to B, you have what? Minus px. Okay. So it is a linear function, right? It's a linear function. So the y-intercept is equal to 0. So you have a gradient over here now, right? So this will go down this way. Because we have minus, this is negative slope, right? Right? So if you see over here, right, if you look over here, minus p means the slope, right, is negative. So negative is coming down, right? If slope is positive, then it's going what? Up. Okay. So we know from here, okay, you know from here, this is the slope, right? And this slope is equal to your what? Negative, okay, p. Right? That's your gradient. Okay, that's your gradient. That's equal to what? Minus p. Okay. So up to here, anyone has any question for now? Anyone, please? Anyone? We're okay? Okay. So now I'm going to go to point B now. Okay. So we're going to go back to point B. Okay. So let's look at point B. Okay. So we now have to look at point B. So at point B, we'll be coming back to this table and drawing and sketching every now and then. Okay, so I know I'll be moving a lot. Okay, so we'll now come to point B. So at point B, x is equal to a. So when you see x is equal to a specific value, okay, we are going to what? We are going to, so the constant or the constant will be calculated. Shear force and bending moment magnitude will be determined. Okay, so when you get this number, it should not be a function of x. I repeat again, when you get this number, it should not be a function of what? A function of x at all. So from here, when x is equal to a, so again, you draw the same diagram at point B now, okay? So this is at point B. So this is point A. And then this is your point where? At point B, okay? So you have a load coming down, P, okay? And you have a reaction force at point B. And the reaction force over here we calculated is equal to what? P plus by omega over 2 L minus 2A. Okay. Then we have at point B. So V at point B and then moment at point B. Okay. And then we know that the distance from here to here is equal to what? Is equal to A. Okay. So from here, we will do static analysis again. Positive, that's going up. Some mention about forces in the y direction is equal to 0. Okay. And then you have P or minus P minus by P plus by omega over 2 L minus 2A. Okay. Then you hold on, then you close bracket. Let me write down here.
Shouldn't that be plus?
So you have, yeah, it's plus. Minus P plus by P plus by omega over 2 L minus 2A. Okay. Then you close bracket again. And then you put minus V as a function of B. The whole thing will be equal to 0. Okay. So V as a function at point B, not function of B, sorry, at point B will be equal to omega over 2 L minus 2A. Okay. So like what I told you, it's going to be a what? A constant number. Okay. It's not going to be as a function of X anymore. Okay. So VB is equal to, so down here, immediately, you write down that VB is equal to omega over 2, right? L minus 2A. Okay, then we do our moment. Okay, so again, where we take our moment, this is the point where we take our moment. Okay, that's the point we take our moment. So we're going to do summation about moment in the Z direction at X is equal to A or at point B. Okay, down here you can directly say that point B, the whole thing is equal to 0, right? So the PA will be going anti-clockwise. So it's going to PA. Okay. And then the M is also anti-clockwise by M. at point B is equal to 0. So M at point B,
Eugene, can you scroll down a bit?
scroll up.